So now that we covered everything there is to know about pure substances, elements, and compounds, we can finally get into the good stuff, and that is mixtures. So let me go ahead and remind you guys one last time, because I know we've been talking about pure substances for a while, what a mixture is. Mixtures are basically two or more pure substances that are mixed together. For example, if you have sand and salt, put them in a bag, shook it all up, mix it together, you don't have a chemically new compound like water or anything. No chemical reactions are taking place. You just have a bunch of freaking sand in your salt or salt in your sand, depending on which one you wanted. Like, why would you do that? Why would you even put salt and sand in a bag and shake it up? That's just ridiculous. There's no need for that. Don't do it. So basically, they're still two very distinct substances. They're just all mixed and jumbled together now. So whenever we look at our graph, we can say, okay, so how can you jumble things together differently and get these two different types of mixtures, homogeneous and heterogeneous? Well, let's go ahead and take a look at that. Homogeneous mixtures are sometimes called solutions because they're uniform or same throughout. For example, if you took some salt and you threw it into a cup of water and you shook it up real good, then you would have salt water. Now, whether you took a sample from the top of the glass or the bottom of the glass or somewhere in the middle, you're always going to have salt water. It's not going to change whether you take a little bit, a lot. It's all salt water. There's nothing you can do about it. However, a heterogeneous mixture is a little bit different. It is not the same throughout and it's not uniform. Think of this as like if you went to McDonald's and you got one of those delicious chicken salads, you would have like chunks of chicken in it, and you would have some lettuce. Hopefully, not too much of lettuce. That's gross. We want the chicken and, maybe some mayonnaise in there. Why not? Throw some cheese in there. So you pretty much have a bunch of crap mixed together, but it still has a very distinctive parts. So while homogeneous mixtures are something like Kool-Aid, where you put everything together, mix it all up, and you can't tell what's what. It all looks uniform and the same. Heterogeneous mixtures is basically just the opposite. It's not the same throughout. The crap is mixed together, but you can still recognize the different pieces. The parts are still very distinct. So now let's go ahead and recap what we learned one last time. Matter is split up into two parts, pure substances and mixtures. I think we covered that enough. Let's go ahead and touch on these four and give you an example of each. An example of an element would be something like gold, where all of the atoms are the same. An example of a compound would be something like water, where you have two different types of atoms. And we'll talk about atoms later on. Two different types of balls. Some hydrogen, some oxygen. That's what you get in order to make a compound. Both of these things are classified as pure substances by chemists. Not me, chemists. Blame them if you don't like it. Now with mixtures, it's pretty much a bunch of pure substances mixed together. A homogeneous mixture is something like Kool-Aid, where you have the what's it called, the flavoring, the sugar, the water. You mix it all together, and there aren't any chemical reactions taking place. You just can't tell what's what. It all looks the same. Heterogeneous, however, is different. It's like a salad. All your crap's mixed together, but it has very distinct, and you can still recognize the different pieces on it. So basically, gold, water, Kool-Aid, chicken salad. That's all you need to know. Thank you for watching. Don't forget to subscribe, and yeah, I'll see you guys next time.